Linear versus nonlinear functions. So we are in a new unit. We are in Unit 3, which is all about writing and graphing linear functions. So before we can talk about that, we need to decide what is linear and what is not linear. So for graphs, a linear function is anything that forms a line when graphed, a single line. So if we look at the left, all of these are a single line, either up or down, and this is a portion of a line. So even this is a linear function, it's just a portion of it. For the nonlinear functions, we have curves. So this is a U shape, just upside down. That's a curve, not a line. This guy is another curve, not a line. And this is also a curve. So if it doesn't create a straight line, then it is nonlinear. Now for the equations, a linear equation is one that has the highest exponent of a 1 and is usually in the form of y equals mx plus b. We'll talk more about that form later on down the road. Now here's a couple other things. The variable x or y are not in the denominator of a fraction, and they're also not the exponent. So I can have an x in the numerator, just not in the denominator. That's the important thing. So if you look at number 1, we have y equals negative 3x plus 5. This is in that format of y equals mx plus b, so this is linear. Number 2, y equals x to the third plus 1. This has an exponent higher than 1, so that means this is nonlinear. The exponent I'm only allowed to have is a 1. So remember, if we do have an exponent of 1, it doesn't show. So in example 1, this guy right here is actually x to the first. We just don't write this little first. So really, there are no exponents on linear functions. So example 3, 2x minus y equals 8. Well, let's see. There are no fractions, so that's okay. I don't have any exponents, so that means it has to be a 1. And my x is not in an exponent, so this is also linear. Number 4, y equals 2/5 x. 2/5 is the coefficient. Yes, it's a fraction, but x is not in the bottom, so this is also linear. Now, example 5 is an odd one. Y equals negative 3. There is no x here at all. So this is like saying x to the 0. And so since this is a lower exponent than 1, this is in fact a linear function. It's actually a line that goes horizontally across my graph. And we'll learn more about that later as well. So for example 5 shows x is 1 over x. X is in the denominator, which is not allowed. I'm not allowed to have it in the denominator, so this is nonlinear. For example 6, y equals x over 3, the x is in the numerator. That's okay, because I can rewrite that as 1/3 with x on the side. So this is, in fact, linear. And then for example 7, the x is the exponent itself, which is not linear either, so this would be non-linear. And finally, we have tables. So with tables, linear functions have a constant change in the x's and the y's, and it's always with addition or subtraction. Nonlinear tables, they change at different amounts, and you can be multiplied or divided by the same number. So linear tables are changing at the same rate with addition or subtraction. So if you look at number 8, let's check our x's. So to get from negative 2 to a negative 1, I have to add 1. Negative 1 to 0, I add 1. 0 to 1, I add 1. So far, this is constant. And it's addition, so this is okay so far. I still need to check the y's. So from 3 to 1, I'm subtracting 2. That's okay, we can subtract. 1 to negative 1, subtracting 2. Negative 1 to negative 3, subtracting 2. This is also constant. So since both the changes are constant and either addition or subtraction, this table is a linear function. If we look at 9, do the same process. 1 to 2 is adding 1. 2 to 3 is adding 1. 3 to 4 is adding 1. Now 4 to 12 is adding 8. 12 to 20 is adding 8. 20 to 28 is also adding 8. So both of these are constant numbers, so this is also linear. Now if we look at number 10, 2 to 3 adds 1, 3 to 4 adds 1, 4 to 5 adds 1. But here, 4 to 16 adds 12. Now, you could also technically multiply by 4 because 4 times 4 makes 16. Now let's see, 16 to 64 adds 48. Or again, you could also times it by 4 because 16 times 4 makes 64. 64 to 128 adds 64. Or again, you can multiply by 4. So this side checked out, but on the y's, these were all different numbers. Now, yes, these were all multiplied by 4, but remember, I can only use addition or subtraction for linear tables. This is not okay for linear, so this is a non-linear function. So linear functions are graphs that create lines. I have equations with x's and y's as non-denominators and a highest exponent of 1, and the linear tables have a constant change with addition or subtraction.